Okay, I think we're live here. Okay, I'm not going to be looking at chat right now because honestly there's nobody there, but it might be open. I will see if I can keep myself on track and get these buttons right. Okay, so in the first couple of hours we did the first 5. And I'm not trying to go fast. I'm just trying to go accurately and completely. We're testing. We're doing everything. Okay, reverse the words in a string. Given a string, reverse the order of the words. Words non-space. S can contain trailing. Do not include extra spaces. Okay, so we're going to use just iterators for this. I'm going to, here's my code. We're going to save as, and we're going to call this part 1. And pub, nope, not here. librs. Pub mod part 1. There we go. So I'm just separating this out into a couple of different versions. Hold on, let me let my dog out. Okay. So obviously now we're going to do part 2. And let's create this and go into it. Config test, tests. Let me just pull it from the other one. There we go. Okay, so test, fn test, reverse words, 151. So we have the sky is blue. Solve reverse, reverse words, 151, and we're giving it the sky is blue. And we want to return blue is sky the. Good. Okay, pub fn solve, reverse words. S is going to be a string reference. We're returning a full string. So let me just knock this guy out. Words equal trim split white space. All right. I can even do reverse on this. Words. What do we do to join? String join. Hold on, I just need to look this up. Rust join words with space. Excuse me. No. You can use slice join. Really? I don't think that works. It's the space that's getting me, right? Because I'm when I'm looking, I'm just trying to get this right, so we're not. Let's try this. Words.map word. We're going to run flat map on it. And I'm going to return word and a space. So now those all have a space, and I don't want we're going to put a space in front of the word. Words skip one, collect. That should do it. Sweet. Isn't that nice? Holy cow. Like, that's just a really, really slick way to do it. I hope you're watching me. Yeah, good. Let's just do another one here. So the output here. There, comma. Good. So this I'm certain is working. Run. And submit. Good. I do wonder how many solutions there are in this. Okay. It's got to be there somewhere. I'm just missing it. Let's go to the next one. That was fun and easy. I don't know why these are mediums. Like, there was other ones that I thought were more challenging in the previous version of it. Okay. Product of array except self. Oh, yeah. I already looked at this. So let's just run the test. I read in the previous one. You can read it if you want. Actually, I'll keep it up while I write the test in the other screen. Input and output. So here we go. Test, what do we call this? Product array except self. What number is this? 238. Assert EQ is going to be solve. I'll let you look at my code now. Solve product array except self 238. And we're going to pass it in that. I think that's right. Hub and solve product array except self. We have values, which is going to be a string slice of, I'm guessing they're using I32s. And we're going to return a vec of I32s. Let sum his values. I can do into iter sum. And we're going to return values map v sum minus v, right? Product of all the elements of num except for that. So it's going to just be sum minus v. Isn't that it? Cannot satisfy. What? Consider giving some an explicit type. Okay. Whatever. So I'm doing this different. Oh, it's equal to the product vol there. So they had 24, except for that. Oh, we just have to divide. It says we can't use divide. We cannot use the division operation. How do we do it without using a division operation? I'm not going to shift. Without using the division operation. Why would you? Runs in order and time. So the obvious thing here is to divide by 0. They're concerned about the 0 and the 1 here. The product of the array. So our self, can we subtract ourself that many times? Like that's why the -1 sorts of things are there. Okay, this will be curious. So if v is less than, if v equals 0, then it's just sum. Else, if v is less than 0, no, we can just do this here. v.abs I don't like this, but whatever. VABS times v.sign signum. I feel like that's kind of doing it. (24, 22, 18, 12). So 1, this is 2. Which means we need to have it. Oh, we can just do it with shifts. Each time we're dividing. Yeah, we can shift. Can we just shift by that whole thing? The product of any prefix guaranteed to fit in that. All these numbers have to be less than three. going the wrong direction. Close. 2, 3 is going to be 8. So we divide 24 by 3. But we don't include that as a product. Come on, math. How do we end up with 6? Because we take 24. We have to minus equal VABs. Shifts are doing divides. Like if I just do it this way, where like this is the an answer. But they don't want the division operator. So why am I blanking on how to do this? Let's do it this way. So we have VABs and let return equal product. While VABs is greater than 0, if VABs equals 1, return is return minus I really dislike that. I need to shift divisor over, right? Each time we're dividing by 2. Signum. It's something like this. Can I mutate this? So the first one is 1. So our divisor is VABS, while divisor is greater than 0. If divisor is 1, we subtract VABS from that, which is 1. So we should get 20. Can we use the modulus? I'm curious here. I want to look up the hint here. I think I utilize the prefix and suffix products. How could the product? Can you pre-compute the prefix and the suffix products in linear time to avoid redundant calculations? Prefix and suffix products. Everything before it and everything after it. They just saying to, I'm just curious, you can minimize additional space uses by reusing memory or modifying the input array. No, I don't like that. Can you pre-compute the prefix and the suffix products in linear time to avoid redundant calculations? Yeah. Okay, so this is what we're going to do. Let prefix is well, we're going to get the sum. Values, skip 1. Error copied product. So that's the suffix. Prefix is 0. So I think now we're really going to compute the so the prefix does not include us. Prefix and suffix does not include us. The return is going to be the prefix times the suffix. Well, 1. I think I have to set that 1. So then we're going to compute the next one. So now prefix is now going to be take out the next one? How do we take out the next one without wow. This is throwing me for a loop. So the prefix will then be the prefix times ourself. And now the suffix you've got to take ourself out. So we take ourself out of the suffix. How do we take ourself out of the suffix without dividing? That was the problem that I had with the other one is sorry, you didn't see my code screen. So all the nums are between minus 30 and 30. So I feel like I can actually just do it with shifts like I was trying to do before. I don't think computing the prefix and the subject. Let me see if I can do this before. Like again. Okay, product is this. Okay, if v equals 0, product can, or there can be zeros in there. So everything is going to be 0 except for that. But if we take ourselves out, that's where the prefix and the suffix need to be in play there. So I was kind of on the right track. The product name guaranteed to fit into that. The inputs, all of the numbers are between minus 30 and 30. That means that you know what? I'm going to, for now, I want to move on just from a sort of time point of view. This gives me the right answer, and I want to just move on. Attempt to divide by 0. Oh. You know what? Screw it. Let's just, let's put in our other test. Let's have this be really bad, but I don't care. Where are we at here? Okay. Brute force. I'm just going to do brute force right now. Time limit exceeded. Let's do see if this runs fast enough. Time limit exceeded. I'm sort of close. I don't think you can do it in just straight end time. Because the suffix do I have to do it with the zero count? The zero is what really gets you. The fact that the numbers are all going to fit within minus 30 to 30 is important here. it's going to be some pre-computing in order 1 extra space complexity. The output array does not count as extra space for the space complexity analysis. So we need to pre-compute some values there. Do I go in reverse order? Yeah, I think I can do that. Values, iter, reverse. I'm just going to do this in the... So for value in values, iter, reverse, copied. All right. Mute accum is 1. Accum is times equal values. Post push accum. So now post is a backward version of what is the postfix of this. So now prefix is this. For VM values iter of all of that stuff. We are going to return, do we go backward? We go forward. So postfix is now I believe we're going to return prefix times postfix dot next unwrap. Prefix is times equal value. I think that does it. I'm going to reverse this. I think I reversed this. Close. 24, 24, 24, 24. 4, 12, 24, 24. I think I have to skip one. Okay, let's see if this does it. Yay! Okay. The hint to pre-compute this is interesting. So I wonder now. You know, I'm not even going to try to do that. I'm okay with this. That shouldn't have taken that long, but let's go to the next one. Increasing triplet subsequence. Oh, given an array of integers, return if there exists a triple of indices ijk that I and all those and nums. If no, then return false. Set up our test. Test. What do we call this? Increasing triplet. 334. Assert. True is solve increasing of 1, 2, 3, 4, 5. And 5, 4, 3, 2, 1 is false. And then this nonsense is true. Okay, let's do this. So, if no such indices exist, return false. So let's just do this with nested ranges. For it's I, j, and k. I in 0 values len, for j in I values dot len, for k in j dot values dot len, if values I less than values j is less than values k, return true. Otherwise, false. And value sub j So that passes. It's kind of a brute force. Is there any, like, could you run in time and space? So this may run out of time. Yeah, our time limit exceeded because you have a lot. So let's fix this from a time point of view. So, so we really just need any three values to be in sequential order. So we have min and max. And we need one greater than min. Yeah, so here, we'll do this. Let min equal values.min. Max is values iter max. Let one in between min. Really, if let's unwrap this. I really just want to unwrap a return false. Here, we'll do that. There we go. There we go. If min equal max, return return none. So, and then one, let one in between min max is values any, iter any, where star v is greater than min and star v is less than max. There we go. That'll do it. So this is really going to return sum of double, and this is none. pass? 334. What? 89. Oh, shit. I want... Let's do this. Values it. Fuck. Values iter enumerate min by v. Right? Close. Expected to take two distinct arguments. Oh. One item and another item. A comma B. A.1. B.1. Expected ordering found bool. So this is really min index and min max index and max. There we go. If min equals max, return on. If min index is greater than max index, return none. Okay, so now we have that separated. So we really just need now the values between those two. So this is going to be min plus 1 to max, if any of those min index. If any of those are in between, then we're good. Cool. That should work now. Wrong answer. Outputted false. Oh. Oh man, I thought that was going to be a really nice solution. But it's not just the min. And the max. So we walk backward. These are, we're in the panels that are in, oh, array and string, 2 pointers. So we really need a 2-pointer sort of solution for this, I think. So let me go back. Yeah, so let's do this backward. This was almost fun, but let min equal 0. Let max equal values.len. I think we can just okay, for I comma value in values iter copied. Enumerate. Copied enumerate. Oh, that was almost good. Now go from the end for okay, do we pre-compute something? We need to create an array that has does this say that there are no repeating ones? No, I think there could be repeating. So if we know where the max is from afterward, yeah. So let's just do let max and we're going to go we also need to know what the index of the max is. think I'm only getting rid of one loop though. What do they talk about with the complexities? Order 1 and order space. Constant time. Oh, and time complexity. Can you do? You probably can, but probably gonna have to walk from both ends, I think. Just gonna check out the hints to see what that. They don't have hints. It's interesting. So this increase in triple is the easy one to do. So I'm actually going to shelve this for a second. We're going to stick with the slow version of this. And I'm not going to submit. And I just want to move on. String comparison. Given an array of characters, cars, compress it using the following way. Okay. String compression. This is more of just an algorithmic sort of thing. input number 443. Those aren't strings. I know I should do this in the editor. Output return 6, and the first 6 characters of the input array should be oh, I don't like that at all, but okay. It's an array of chars, and we're going to output a vec of chars. Compare char 6. There we go. Okay, so this is just a rule set. So we're going to do input. I mean, we're sort of we got to do this. Okay, given an array of characters, compress using this. Begin with an empty string s. What a horrible way to do that. After you're done modifying the input array, return the length of the array. Okay. For each group of consecutive repeating chars. Okay. So let previous is going to be none. We're going to loop. And let new cur is going to be input.next. While cur is some. So we really need let for char and input, for C and input. I haven't wrapped my head around this. There's some pattern with this. Rust option else unwrap pattern. Yeah, you know, let's just do this. Next C is that. If let next C equals, yeah. There's a better version of this. There's something with an else sort of thing. Okay. Oh man. I think I can borrow that. So let count equals input by ref it's like we have to peek it. Gosh, I really don't like this. I feel like I really just need to take a break. Like I burned myself out. Let's do this. We're going to do this with like slices. So this is really going to be while input size, input len is greater than is. While it's not empty. C is going to be input sub 0. Input's going to be input sub 1 through the end. Consider borrowing here. Sure. So now how many? Count is going to be input iter take while v equals c, writing a star there, at least a star. Count, probably +1. Let out equal vec new. Return is that. So we can only go up to 10. Will be split into multiple characters. Okay, so while count is greater than 0, might be off by 1 there. While count is greater than 0, we are going to go, well, let's do ret push c, ret push this is going to be like an actual 0, 1, 2, 3 sort of thing. Can I do that? How do I get an ord of that? Ord of a plus and we have another into. Oh, we are trying to. So ugly. Wow, that worked the first time. Let me copy in the next set. I don't think that's going to be right for my input here. Returns 4, and the first 4 characters input. The groups are A and B. 12 will be split into multiple characters and chars. Oh my god. Okay. Well, let's just fucking do this. This is ugly. Push that. Append. Extend from slice. Format bang. Count. As slice, right? Can I? We should be able to do ret extend chars. That should do it. If it's just the one, then we just append. If count is greater than 0, 1. Okay. How do we... There's a way to overwrite this. You take a slice and you... The input won't always be... Screw it, let's just do this. Chars equal return return.len. There we go. I don't really care for that, but whatever. Here's our version we put in. It works. Beats 100% of probably not many. Whatever. Move zeros. Given an integer array M, move all zeros to the end while maintaining the relative order of the non-zero elements. You must do this in place without making a copy. Okay, we're just going to shift. I've... $283. Output is this. It's going to be a vac, right? Oh, we have to do this in place. Fine, I'll do this in place. Well, I'll return a reference. Solve move zeros 283 of nums. Right? Oh, I 32. A reference to mutable, all of that. Good. Types differ in mutability. Oh, right. Input. Okay, all the zeros are just at the end while maintaining relative order of the non-zeros. So we're just gonna for I in zero values len if values of I equals 0, we need to shift in 0. I can't. And I think that'll do it. If value is 0. What happened here? Provide values to n, values of I. Oh, you should really be looking at this. Man, I am a really bad streamer. I just want to make this crystal clear. What is that? 0 and 4, 3, 2, 1. Zero, 1, 3. Oh, it's because we shift down and we need to well, the 0 thing is not right. It works fine for oh, I wonder. Let's do this. Oh, I like this. Non-zeros is values iter filter v does not equal 0. All right, okay. So now we just do next value is going to be remove non-zeros dot next. Okay, unwrap or 0. Easy. Okay, so then all we need to do is go values iter mute for each star v is next value. God, move that. Those have got to be mutable as well. Not by our values is mutable because it also borrows immutable. Okay, this is that I think I can do this. Let values equal I need this to be in a ref cell new values. Okay. So this is the thing where I'm going to change this. So I do want next value. Let next value is going to be, we're going to wrap this in here. Let mute index equal 0. Move if let sum we still have to borrow that as immutable. I'm trying to do this right with Rust and its immutability issues. And I still think I have to do this. I think I have to do that. Yeah. So a little wonky, but this will give us the next value. So what I think now for I in 0 values.len values borrow mute get mute I equals next value. Borrowed moved values. Don't move that. I think I can actually do this with a cell. Panicked, already borrowed. star V. Hey, I did it. Okay, let's put this into place. Yay! Okay, here's the solution. Let me let my dog out. You want to go outside? I think probably after this one, I'm going to have to take him for a walk. So let's walk through this. I didn't get a compile error here. It worked. And so I have to do a sort of a trick here because you have to, well, at least in the way that I have it set up here, you have to have different mutable access to the content. And it's mostly because I have this next value here. And I'm trying to store this in a loop. Well, in a where the state is kept here, but unfortunately you have to have sort of an immutable and mutable reference. That's why we have to use refcell to manage the mutability. And because we have two versions of it, we need to have RC. I think there's anyway. This next value is here. Say we're keeping an internal counter of where we are in the original list, and we have this little loop here that says, okay, every time we try to get another value, we're going to try to get a value from it. And if we don't get a value from it, like we're at the end of the array, we're going to return 0. Otherwise, we increment our index and we return that value if it's not 0. Basically, this is a filter sort of thing, but we have to have mutable and immutable access to it, unfortunately. And we could actually move this in here and not have to deal with the RCs. Maybe I'll do that. Where are we at with our code here? Oh, we've already gone into the 2 pointers. Yeah, 2 pointers. That's a. Let me do this without a borrow. So read index is going to be 0. value sub read index, value stack get read index if value equals value does not equal 0, then we return value. So let me just nuke all this stuff. And I just want to oh, you're not looking at this? There you go. So here's my non-borrow version of this. Read index loop, read index value star. I think that does it. Yep. Values sub I equal value. So we just need this to be mutable, and we should be off to the races, which we are. Okay, I actually like this a lot better. I want to submit a different version of this. So we don't need any of that stuff. Let's run this. Good. Submit. Good. So this is just a lot cleaner. Let's look at what we have here. So like our pointers in Rust, especially if you have multiple ones, they're generally going to be indices. So this is our writer loop sort of thing, where we're going from 0 to the end, and we are updating it with some new value. And the new value that we're going to be using here is, and we have to use loop. And to use loop as an expression where we break a value is really, really slick, I think. So we are getting the next non-zero value out of it. And again, kind of unfortunately, we have to keep our iterators. We can't use iterators in this without it being just ugly, messy. So we have this, we try to get our read index. And if it's within the range, we say, okay, let's go to the next one, because we're going to do something with this. And if it's 0, then if it's non-zero, we break saying we're going to use that value. Otherwise, we're going to loop again, take the next value. So this part here is skipping values in it. If we've hit the end of the array, we break with 0 because we're going to 0 backfill it. So now this is just getting the next value from our array, and we're always going to be either at or ahead of it. But actually, well, yeah. And actually what we can do here is we're going to assert that read index is greater than or equal to I. It's just like a sanity check. But I like that. This one was neat. Let's see, where are we at? We have, Well, we just started 2 pointers. Let me do one more. This will take us to 1 o'clock, and then maybe I'll go walk the dog. My dog will be very appreciative. Given 2 strings S and T, return true if S is a subsequence of T. Subsequence of a string that is formed from the original string by deleting some of the characters without disturbing the relative positions of the remaining characters. Oh. Okay. Yeah, this is close. So let's. I think I can knock this out pretty quickly. F and test is what number? 392. And assert equals true for is ABC and Alcabra. And then the next one's going to be false for ACX and alcohol. So to do this, I'm going to do this recursively. So if S is empty, true. Otherwise, pos is going to be T position of C equals S of 0. How do I get the substring of that? Like we really want. Oh, let's make this. It's an iterator of item is character. And T is also going to be an impl iterator, item equals character. I think these are going to be mutable. So let's do this. Next S is going to be S next if next S if empty turn true. Okay, so next S is now expected bool found. There we go. So that's the next S. Cares. Take while C does not equal that. Really, that's not what I need to do. For next T and T dot next T dot by ref if next T equals does not equal next S, do we then free edge? Yeah, we're just going to do it that way. Gosh, I don't like that. S T to pause to the end. I think that's going to do what I want. Okay, so this is all working correctly. Our solution here, so we just have, let's get the next thing that we're looking for. Find the position of the character we're looking for. Doesn't exist. Isn't a subsequence. And we could actually do this differently. Let's do this in a loop. We do this, and t is just going to be at t sub pos dot dot. Same thing. Here's our base recursive case. Otherwise, we do that. So now that I think about this, I think that we can continue to take it. No, we can't take it while. No, we can't take it until we find it. So I do think we can. I think we can do this with an iterator. Without collecting. Okay, so T is now going to be a impl iterator item equals care. I think we can actually do this t dot by ref iter, not iter, position where t is that v if is some. Actually, if it is none, that should do it too. What? Expected at car. Oh. I did the wrong one. It's okay. Good. So, a little cleaner one. Let's go to the other thing. That's really slick. I do like that one a lot. Run that. And submit. Let's Nice. I feel like these are actually there must be a lot, because like if this were if there were only 5 submissions, anyway, I could figure that out. So cool. Okay, am I gonna walk the dog now? Let's look ahead. The only one we didn't do is this increasing triplet sequence. Container with most water. I think what I'm going to do, since there are different categories of these, what we're going to do is we're going to skip around. We're going to pick one from each category after this, and that's what we're going to work on. So let me look ahead here. Average subarray. You're given an integer array nums consisting of n elements and integer k. Find a contiguous subarray, whose length is equal to k, that has the maximum average value and return. These are sliding windows, right? Yeah, these are all sliding windows. Shoot. Yeah, you're still looking at that. Any answer with a calculation error less than something. Oh, that just means like use doubles or something. Yeah. This is an easy one. Okay. Apologize to my dog, but I just have to kind of do this. Test fn test max average subarray. Blush. I know it's me, but shh. Assert EQ, bang. $6.43. Probably about right. So values, these are going to be I32s. Yeah. And K is a use size. Return an F64. So there are some permutations here. So let ranges equal 0 to values.len minus k. Start to start plus k. Good. So now we'll just do values equal values or ranges map range values get range, we can unwrap. Good. And now values max. Map. I need to reduce. So we reduce it by, our reducing function is something. It's the same as fold the first element of the iterator as the initial accumulator value. Oh, that's fine. We can really just sum this. As f64 divided by v.len as f64. I think that's right. And then we just want the averages dot max. Unwrap or 0. Word is not specified for f64. Max by 0. Why would that be 0? I guess sort of a trick. If k equals 1, I should still be able to do that. But it's going to be that. So ranges goes from 0 dot dot I think that's what I need. Yeah. Let's see that this works right here. So I do wonder here if I'm do I have a concurrent viewer? So part of this is we're recomputing that range all the time instead of like, taking out the previous value. So let me just fix that because I want this. So I could do this if I was using this sort of like for loops. Okay, let's go ahead and do this. So our ranges are sort of fine. So what if we do this? Let for r in ranges. Let previous sum is going to be ranges next by ref next map values get unwrap map v sum iter sum I32 unwrap good. There's our previous sum. Let mute max is going to be the previous sum divided by k as f64. Cannot divide. Oh. Good. So now for R and ranges, let values equal to values get R unwrap. No. We really just need to this sum, I can just say previous sum equals previous sum minus value sub R minus R dot start minus 1 plus values R dot end of this sum, this average equals previous sum as F64 divided by K as F64. If this average is greater than max, max equals this average, return average max. Sweet. Almost sweet. This may not have actually worked. Yeah, I don't think so. Linus 6, but yeah. I wasn't sure if end was going to be at the end, one more or one less. So let's do this version. This should be notably faster. This should get me down to that 0 range. Two. No, do it again. Okay, I'll take it. Let's go walk a dog because now my cat, where's my cat? Now my cat's yelling at me, probably yelling at me to go take the dog for a walk. So, I'm going to look ahead. There's my camera. Highest altitude. Biker going up a road trip. What are we doing? Prefix sum. Biker's going up a road trip. Road trip's a bunch of points. Biker starts his trip at some point with altitude equals 0. Give an array gain, or gain is a gain of altitude. Return the highest altitude. Oh, this is just that's an easy one. Hash map set, difference of two arrays given to 0 indexed array. Why do they say 0 indexed? Return a list, an answer of size 2, where answer 0 is all the distinct integers and num1 that are not present. Okay, I'm just going to fill hash maps and stuff like that. Stack, removing stars. Okay. This looks good. I'll be back in an hour or so. Hopefully with a happier dog. We're going to go to Forest Park. So this should be good for him. Good for me too. Okay, out of here.